Alright, in this video we're going to talk about the Unit 5 Quiz 2. I went ahead and got my calculator so you'll know exactly what I'm doing. And so let's go ahead and get started. Question number 1. In a proposal for a local city has been polled and the results are shown below. Alright, so all of our information plus our margin of error. So when using the margin of error, how many people were actually surveyed? Well, it's 1.09, and if you remember, my setup is going to be 1 divided by the decimal, and I'm going to get a number. I'm going to square that number. Okay. Now the only thing to remember is this: when you are dealing with the decimal, make sure you move, or percentage, make sure you move it back. So it's going to be 1 divided by 0.019 is equal to a number, and then I'm going to square it. All right. So here we go. So 1 divided by 0.019 percenter, and I'm going to square it, and I'm going to get 2,770 rounded to the nearest whole. All right. Then from here, based on the results, what is the percentage interval that will vote for yes? Now remember, this is a good day, bad day situation. Okay. So this is a good day, bad day. So that means the yes, we're going to add 1.9% to it, and then we're going to take yes, and then we're going to minus 1.9%. All right, so when you do the math, I believe that is 40.1 to 43.9%. All right, now after that, a lot of folks are still screwing up on this. If 15,000 voters were to vote in this election, what is the range? So we already know that the interval is going to be basically 40 to 44%. Now what we've got to do is that 40% of 15,000 voters, 40% will vote. So off to the side, it's going to be 15,000. Now remember, guys, when you're multiplying by a percentage, you always move the decimal. Some of you guys are still not moving the decimal. So 15,000 times 0.40. 15,000 times 0.401. That gives me a low end of 615. And then 15,000 times 0.439. 6,585. All right. So remember, take the previous answer, multiply it by whatever number happens to be in the situation. All right. There we go. Next, we have a histogram. How many trees were represented in this histogram? All right. So let's go through it. Now, this is kind of throwing some folks off, or throwing some people off, and that is, this goes between 2 and 4. Guys, the number between 2 and 4 is 3. You'd be surprised how many people are screwing up on that. 3, 3, this is 8, this is 10, this is 5, this is 2. All right, so let's see, 6 plus 8 plus 10 plus 7. All right, so that's a grand total of 31 trees. Now from here, how many trees have a height between 75 and 85? All right, so 75 is here, 85 is here, and it's everything in between. So that is this column and this column. So that gives me a grand total of 15 trees. Happen to be inside of that range there. Now my next question is, what percentage of the trees have a height that's smaller than 70 feet? All right, so 70 feet is right here, and smaller is this way. So I have a highlighter, hopefully you can see it. So 70 is here. Everything that is smaller, which is those two columns, which you can't really see, these two columns here. So that's a grand total of 6. So remember, when I'm looking for the percentage, it's what I want. Let me see. What I want over the total. And what I want is 6 trees over 31. So 6 divided by 31, enter. But remember, you move the decimal 2 places over, which you can multiply by 100, which gives you 19, and we're going to round to 19.4. All right. So moving on. Here's another histogram. How many people are represented in this histogram? Well, let's see. This is 25. This goes up to 100. This is 25 again. This is 50. And this right here is 75. So add them all up, and you get 275. Now, what is the overall test average? Now, remember, 25 people got a 100. So 25 times 100, because there's 25 100s. Plus 100 people got 90s. So 100 people times 90. Plus 25 people got 80s. 25 times 80. 50 people got 70. Plus 50 people, 70. And lastly, 75 got 60. Plus 75 times 60. Okay, so here I go. 25 plus, notice how I'm doing my parentheses. Alright, so 21,500, but you're finding the average, so I'm going to divide that by 275. So divide that by 275. My answer is 78.2. Alright, so 78.2. Now, next question is, which of these histograms are considered skewed left? Remember, it's always opposite, so basically, if it's anything skewed left, you're looking for where all the information is on the right, which would be B. Alright, remember, that's always opposite. All the information is on the right, you need it to be over here, so that would be skewed left. I know it's weird, but it's just one of those things. Alright, so if 3,250 people participated in the survey, what would be the margin of error? Now remember, the margin of error formula is 1 over radical n. Okay, since that is our population, that is going to be what n is. So 1 divided by radical 3,250. So 1 divided by radical 3,250. Now remember, you're going to get a decimal and you need to move the decimal over to a percentage. So 1 times 100. When you times by 100, the decimal moves automatically. And so you get 1.8. Alright, so, but if you didn't want to do that, let's say you're like, okay, that's 0.01754. We'll just stop there. Move the decimal, boom, boom. There you go. 1.754, which rounds to 1.8. Now, if the margin of error is 5% or 0.5%, how many people were polled? You'd be surprised how many people screw up on this. Guys, this question is no different than the very first question, which was this right here. You're doing the same exact thing. The difference is it's just not a part of a little setup here. I just gave you an individual question. So 1 divided by the decimal is going to give me a number, and I'm going to square that number. Alright, so now I know that's a decimal, but it's still a percentage. So it's going to look like 1 divided by 0.005. I'm going to get an answer, and I'm going to square that answer. Alright, so 1 divided by 0.005, square the answer, and you get 40,000. Okay? The following graph represents students who are all scored. Okay, now we got to find an equation. It's going to be y is equal to something, x plus something. Remember, this right here is the y-intercept. This takes you a second. Where does the line go into the y? Boom, right there. At 10. Okay, but we also need that coordinate. Alright, so that's going to be 0, 10. Alright, now we're going to follow along to see if we can't find another exact coordinate. See how like that line goes through half of that coordinate? Now it goes directly through that point there, but that point is not sitting directly on a coordinate. So just keep going, keep going. Still. Oh, there it is. Look at that, right there. There it is, right there. All right, that's where it goes through exactly. All right, so that is that's 90, 60. 90, 60. Remember that this is x1, this is y1, this is x2, this is y2. All right, and if you remember, the formula is y2 minus y1 over x2 minus x1. All right, so 60 minus 10 over 90 minus 0. 50 over 90. All right, now we can convert that to a decimal. 50 divided by 90. 0.555555, so I'm just going to say 0.56. There you go. Notice that my slope is positive. and my slope is going up. All right? All right. Now, we have a situation where now the slope is going down. And I'll be honest with you folks, slope going down, that's going to be a negative slope. All right, so it's going to be negative. So that means your answer is going to have a negative slope to it. So again, same as that question, different numbers. So y is equal to something x plus something. Now this something here is the y-intercept. Now guys, this is not, here's what a lot of folks are calling this. And I saw this a lot, 90,500. Guys, that's not in between 90 and 100,000. What's in between 90 and 100,000 is 95,000. All right, so it's 95,000. So that's my first point I'm going to use. 95,000. My second one, let's see. Oh, there it is. It's going right through that coordinate there. Right there, and that is 180,000. All right, so this is x1, y1, x2, y2. All right, so 80,000 minus 95,000 over 100 minus 0. All right, so that's going to give me negative 15,000 over 100. When I do the math, I get a slope of negative 150. There we go. Now, from here, now obviously, if you get this question wrong, this question is going to be wrong too. So this is kind of a continuation. So if the company produces 500 units, now you know 500 has got to go somewhere. 500 is either going for X or going in for Y, but you're like, I don't know which number it goes into. Well, look at your chart here. Notice units sold, units sold is on your X. So that's on your x-axis, so that means 500 is going in for x, which is right here. So my work is negative 150 times 500, parenthesis, plus 95,000. All right, so we go to calculator out. So negative 150 times 500 plus 95,000. And that gives me 20,000. Alrighty. Alright, this is one where we learned this the day before, so some of you guys might have had some trouble. Alright, so it says 70% voted for Toyota. Ooh, I don't know why I drew that there. 70%. Alright, that's the line right there. This line. Okay? There. That's Toyota. All right. I'm hoping that didn't freeze up. For some odd reason, I just looked at the screen and the thing froze. So let me. All right. So this right here is Toyota. Okay. Now it says 60% Honda. So go to Honda. There we go. So I'm going to go this way. All right. Now. Remember, for Toyota, I shaded up. For Honda, I shaded to the horizontally. All right, so let's start labeling some of the stuff. All right, this right here is the shared section. All right, this right here is the neither. All right, now notice I shaded up and down for Toyota. That's up and down, so this is going to be Toyota only. Up here is Honda only. Okay, now let's go ahead and get our dimensions. This shared section, it is a 70 by 60 box here, which would give me an area of 42,000. Sorry, 4,200. That shouldn't have been there. Sorry, 4,200. This Toyota only, this is a, let's see, that's 60 to 100, so that's 40. Let me go ahead and put my distances on here. I should have done that. This was 70, this would be 30. This is a mirror image of that, so 60, 40, and that's a 3070. This also will be a 3070. Sorry about that. 40 times 70, that's 2,800. This neither section is a 40 by 30, which is a 1200. And then lastly, that's a 30 by 60, so a 30 by 60. And this right here is going to be 1800. All right. So if you can get all this correct, meaning if you can get the labels correct, then it's going to help you out tremendously. All right. So Toyota only. So 2800 over 10,000. Now you might be saying, where did I get 10,000? That is the area of the whole model. So 1800, 1200, 2800, 4200, all that is 10,000. So that gives me 28%. The Honda only right there, that's 1800 over 10,000, which gives me 18%. The both, which is the shared, that's 42 divided by 10,000, 42%. And then lastly, the neither is 1200. Oh, keep on putting 12,000. And that is 12%. Okay. Now, find the approximate amount of students for each category. Now, notice that 7,000 people voted. So what I'm going to do is I'm going to take 7,000 and multiply by the percentage. So that'd be 7,000 times 0.28, because remember, whenever you multiply by a percentage, you always move the decimal. So that's 1,960 people. 7,000 times 0.18, 1,260. 7,000 times 0.42, 2940. And then lastly, the neither section, and that's 7,000 times 0.12, that's 840. All right. So again, if you can't get the area model right, then everything else will be incorrect. All right. Now the very last one is this guy. All right. Now a lot of you guys were having trouble with this guy in the sense of, what the heck do all these dots mean? This dot represents that there is a 2 there. So if I was to start making my list, that's 1, 2, 6, 6, 6, 10, 10, 10, 10, 112, 14, 14, 16. All right. Now what I'm going to do is I'm going to start dividing this up. Okay. So starting here, let's find our median. Here, nope, there. Oh, we have a shared median, so that means it's going to be right here. Okay? Because it was a shared median between 10 and 10. Let me highlight. A shared median between 10 and 10, so we had to make a average on that one, an average. So let's do the median of this. So 10, 16. So starting here. Oh, we have another shared. It's shared between 12 and 14. So that's going to be 13. From this 10 to 2, it's shared between this 6 and this 6, which means it's going to be 6. Okay. Now this is my smallest number. This right here is my largest number. So this right here is the min. This right here is the max. Okay. Now what I'm going to go ahead and do is I'm going to go ahead and make my box graph, because all you need is 5 numbers, and it's the 5-number summary, which is this guy right here. So 2, 6, 10, 13, 16. So I'm going to box in my middle 3 and whisker out to my outliers, if you will. All right. Now from here, we're just going to go ahead and fill everything else out. It's on the back side of the paper. So let's see, the minimum ended up being 2, the maximum was 16, the median was a 10, the lower quartile was a 6, the upper quartile was a 13. Now the range is the difference between my maximum and minimum. So maximum was 16, minimum was 2. So 16 minus 2, that gives me 14. My interquartile range, that is the difference between the high and low quartiles, or I'm sorry, not high, upper and lower quartiles. All right, so my upper quartile was 13 minus my lower quartile was 6. That gives me 7. All right, the last one is the mean. We're adding everything up. All right, so going back to my list here, let's see. 2 plus 6 plus 6 plus 6 plus 10 plus 10 plus 10 plus 10. Now I'm not adding these numbers down here, I'm just adding the entire list here. Plus 12 plus 14 plus 14 plus 16. I got 116. I'm dividing it by, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Dividing that by 12. 9.7. 9.7. Alrighty. That's it. Hopefully you learned something. So whatever mistakes you made, I hope that you never make those mistakes ever again. Thank you for watching.